So this is going to be the last component for the chapter 7. We are finally finishing the chapter 7. We began February 27. Today is what? We almost took a month. Almost took a month to finish this chapter, which is because spring break as well as this coronavirus outbreak. So if you recall what we have done in chapter 7, at the beginning we discussed the overview and we discussed the quality function deployment. This is a tool where the product designers can use to link the customer's demands and needs and wants, and you combine that with your existing manufacturing design capability and finally come up with an area where you can focus in terms of product delivery. Okay, and then after that we looked at the target, tolerance, and Taguchi loss function. I think we did Taguchi loss function just for one session, and then we entered into the spring break. We were able to study the Taguchi loss function. The key here is that Taguchi loss function identifies this profound truth that even a slight deviation from the target can still incur the cost. Okay, so this is actual cost data. We can model in this fashion, and it can help you find out the expected loss for a specific quality dimension. That's one component, okay, one product, one unit. And it can also help you figure out the expected loss for your manufacturing process. There were many different ways you can calculate the expected loss, but the key is that you need to always obtain the variance as well as the expected deviation or the mean difference between the process average as well as the target. Okay, so and then we start to talk about this reliability thing starting from the last week. We looked at the single component reliability. We are looking into system reliability today. We discussed all possible scenarios in here, okay, which did a pretty thorough review and overview. We talk about the failure rate. We talk about exponential failure rate and mean time to fail and mean time between fail and things like that. And today we talk about how to calculate the reliability for different type of system in its highest level of description. And after that, I think we are ready to wrap up. And last component is actually, if you're interested in the last component, you can actually do some in-depth reading on your textbook because it gives pretty interesting cases and examples and so forth. So if you recall, we are so far following the design for Six Sigma pattern. Okay, design for Six Sigma pattern. So Six Sigma has a lot of abbreviation like this. DFSS is nothing but design for Six Sigma. Okay, so if you look at all of the things we've done so far, we are remaining in the design for reliability phase. But after this reliability was determined, you are moving on to the design optimization and design verification. So in the design optimization phase, the key thing you do, of course, there are a lot of things you need to do with the design optimization phase. You need to design a product that is optimized for the manufacturability, and as well as it is very robust. In this case, what I'm trying to say is it needs to be very robust. Okay, design goods and services that are insensitive to variation in manufacturing processes and when consumers are using them. So I think I explained this example in the class. The curved glass in the beginning wasn't a very robust manufacturing design because it is very, very sensitive to the variation during the manufacturing processes. Okay, and also the glass bag of your cell phone is also very, very sensitive to the drop and a scratch. So things like that needs to be addressed and considered. So there are various of tools and steps and processes you can take to address these concerns and issues. I'd like to highlight two things you can use in the design optimization phase. Okay, of course, you see that DFMEA, this is also called FMEA, fault tree analysis, and design for manufacturability, a design for environment, design for excellence. Last three components are pretty straightforward and self-explanatory. So I'd like to highlight these two things. Okay, so design for design failure mode and effect analysis. So as what it is saying from its name, it identifies all the potential failure mode and what is potential effect of such failure. So you use the past record and your professional judgment to develop a huge list of potential failure as well as its potential effect. Okay, so first you're analyzing the failure mode, and then you're analyzing the effect. So this is one example of FMEA analysis on ATM machines. So step in the process, insert card. And what are potential failure you can anticipate? Not inserting card. Insert card wrong direction, which we do all the time. And insert wrong card, right? Insert wrong card. This can also happen. And the failure cause, and it also identifies the failure effects. Not getting money if you don't insert the card. Spits card back out. And the third one is proceed to withdraw from wrong account. Okay, I'd like to know whether there's a way that I can insert a MasterCard and it can give me infinite amount of money out of ATM. I don't know whether that is possible, but you see this point, right? In the failure mode and effect analysis, it identifies all the potential failure mode. It also identifies what is the potential effect. It also weighing on the potential, severity of those failure, and this is what FMEA analysis will do. Next one is called a fault tree analysis. You are developing a this sometimes is also called cause and effect diagram. This is identifying the potential failure from very top, and then you're developing the tree to the very, very bottom based on your technical information as well as the professional judgment. So for example, you'd like to consider what is causing harm to patient, right? You can think of a lot of things. I think this diagram is highlighting the electrical shock. What is causing electrical shock to the patient, which eventually will cause hazard to a patient. You keep developing it. But if you look at some of the node in here, they look different. Some of them means and, logically. Some of them mean or. So when it is and, you need to avoid both from happening. For or, you need to avoid either one of them from happening. Okay, so eventually you can draw a very, very tall fault tree analysis that can help you, in a hierarchical fashion, help you develop what are potential faults can occur during the production or the service delivery processes. Last step is the design for verification. This is the final stage in design for Six Sigma. You do design review. You also do the testing, okay? But this design review is no means linear, okay? I'm not going to pretend I know more than I do. I actually do. But common sense tells us this should not be a linear process, meaning that we've done review, then we're done, everything is good. You kind of have to do it iteratively, okay? You kind of have to do it iteratively, and this is where some of the soft technique will be needed in order to open up the conversation, discussion, things like that. And it is typically conducted in 3 major stages: preliminary, intermediate, and final. Okay, and design testing. I've shown you the video. I think the Thursday that how they do the extensive design testing. They do the live testing. Let's say you are. I hope you still remember the bathtub model. If this earlier life is the length of early life, if you think that the early life in the product life cycle is like approximately 100 hours, that means in the lab testing you do 100-hour live testing. Okay, accelerated live testing, they're gonna overstress device to reduce time to failure. Okay, and highly accelerated live testing, you get what this is about. Okay, and before I close, I'd like to show you an interesting video. This is pretty fun to watch. Okay, who would have imagined this kind of situation? We talk about all these potential failure mode and failure fault tree analysis, but things can actually happen from unexpected angle. I mean, today's product designer are really they need to prepare all sorts of different possibility. Okay, so you can enjoy this video on your own. I'm not gonna play it here. So I think this can conclude chapter 7. I'm gonna post you some more exercises and some review questions so that you can get prepared. Next Thursday, we're gonna move on to chapter 8. Thank you.